Alright, so first thing that we want to do with this integral is we want to put it in a simpler form. So we're going to make the substitution y is equal to x divided by 2. And then if we arrange that, we get x is equal to 2y, and d of x is equal to 2 dy. Rewriting our integral, we get, we get 2y times sine of y times 2 dy, which is equal to 4 sine, 4y sine of y dy. So now what we want to do is we want to solve this by integration by parts. And to do that, we're going to identify our u and dv's that are most convenient. So we're going to set u equal to y, and then consequently we get du is equal to dy. And if we set dv equal to the remaining bit of the expression inside the integral, we get sine y dy. And then consequently, v being equal to this, or equal to the integral over all the dv's, we get v is equal to integral over sine y dy, which is equal to negative cosine of y plus an arbitrary constant. But since we're going to be taking the integral of this expression again, we're going to save that for the end. Now we just plug and chug, and we get y times negative cosine, we need to remember to multiply this whole expression by 4, negative cosine of y minus integral of negative cosine of y dy in parentheses, which gives us negative 4y cosine y plus, and so if we do plus plus, we end up with the integral of cosine y dy, and that is just going to be equal to sine of y plus an arbitrary constant. And need to multiply this by 4. And 4 multiplied by an arbitrary constant is just an arbitrary constant. And then we replug in our original substitution, and we get negative 2x cosine of x divided by 2 plus 4 sine of x divided by 2 plus an arbitrary constant as our final answer.